We're doing 10-2 part 2 today. This is the second part of rational exponents. And we're going to do objectives 4 and 5 today, which is simplify expressions with rational exponents and simplify rational expressions using, or simplify radical expressions, using rational exponents. So those are the two parts we're doing today. Let's look at the first part. We're going to simplify, actually we're doing three parts, I take that back. We are also doing using the definition of a to the negative m over n. We're doing that too for our objectives. So let's look at that. The definition of a to the negative m over n says if a to the m over n is a non-zero real number, then a to the negative m over n equals 1 over a to the m over n. So we are putting a 1 over top of it and changing to the negative exponent to a positive exponent. That's how you deal with a negative exponent. We don't like these negative exponents, so you make them positive by putting them underneath a 1. So you put them on the bottom of a fraction is another way to think of it. And the 1 is what goes on top. So let's look at a couple examples. Example 5 says, rewrite each expression with a positive exponent, simplify if possible. And so we know we got 36 to the negative 1/2 for a. We want to make that positive, we're going to make it 1 over 36 to the 1/2. And this is going to be really hard to write in here. 1 over 36 to the 1/2. We also know from yesterday that 36 to the 1/2 is the same as the square root of 36. So we got 1 over the square root of 36, and 1 over the square root of 36 is 1 over 6. So that's A. B, we got 125 to the negative 1/3, and we can rewrite that so that it has a positive exponent by putting it under a 1. So it would be 1 over 125 to the positive 1/3. And remember, raising to a 1/3 is the same as the cube root. So 1 over the cube root of 125 is what we have, and the cube root of 125 is 5, so we get 1 over 5 as our answer. Let's look at C now. We're going to make it a positive exponent, so we're going to make it 1 over 16 to the 3/4, and we can change that. We learned yesterday we can change that to the 4th root of 16 cubed. So we got 1 over the 4th root of 16 cubed. Fourth root. Yeah. Whenever I try to fix it, I just make it worse. 4th root of 16 cubed. The 4th root of 16 is 2, so we get 1 over 2 cubed. See if I can make that better. 1 over 2 cubed, which is 1/8. So that's that answer. And we got 1/6, that's the first answer. D, 7xy to the negative 4/7. We got to write it with a positive exponent. I'm going to write it over here so I have a little extra room. That's going to be 1 over 7xy to the positive 4/7. And I know this is not the best way to do this here. 1 over, got to make a bigger 7xy. Try this again. 1 over 7x y to the positive 4/7. That's a little better. This is a parenthesis. And we can write that as a radical. It would be 1 over the 7th root of 7xy all raised to the 4th power. And that would be our answer. That's as far as we can go, because we can't take the 7th root of a 7 or the 7th root of x or the 7th root of y. Alright, so pause here, try your checkpoints. Come back. When you come back, I'll give you the answers. So the answer to A is 1/10 in checkpoint 5. B is a half. C is an eighth. And D is 1 over the 5th root of 3xy to the 9th power. Let's turn to the next page, and we're going to talk about the properties of rational exponents. So, properties of rational exponents. Right here. All the exponent rules that you learned in Algebra 1, they still apply with rational exponents. That's with fractions as exponents. So the first one, if I'm taking b to the m times b to the n, if I'm taking two numbers that have powers, then I can add the powers, b to the m plus n. And in the second one, if I'm dividing b to the m over b to the n, then I can subtract the powers, b to the m minus n. The third one, this is raising a power to another power. So b to the m, that's raised to an n. That's when we multiply b to the m times n. And this one is a product raised to a power. You've got a times b raised to the n. That means we can raise both the a to the n and the b to the n. And then a quotient raised to a power means we raise both the a and b to the n power, so a to the n over b to the n. All those rules you learned in Algebra 1, they still apply with rational exponents. Let's start using some of these. So we're going to simplify in example 6. 6 to the 1/7 times 6 to the 4/7. When we're multiplying with exponents, same base, 6 is the base, then we add them. So we're going to have 6 to the and I don't know why, but I can't erase right now. So we're just going to have to deal with it that way. 1/7 plus 4/7. That's going to give us 6 to the 5/7. And we're going to leave it just like that. B. You got 32x to the 1/2 over 16x to the 3/4. The base numbers are 32 and 16. We're going to be able to divide these numbers. The big numbers are the base numbers. You can actually divide them. So 32 divided by 16, that's going to give us 2. And the x, we're going to leave as x, but would these have exponents? And when you have exponents that are being divided, you subtract them. So we're going to have 2x to the 1/2 minus 3/4. And half minus 3/4, if you have a calculator, it can do it for you. I don't have a calculator on me, so I'm going to have to get a common denominator. So that is 2x 1/2 is the same as 2/4 minus 3/4. That gives me 2x to the negative 1/4. 2x to the negative 1/4. Okay, so now I have a negative exponent. I don't want negative exponents in my answers. So I've got to get rid of that negative exponent. Well, we learned in the last example, example 5, that we can get rid of it by putting it underneath a 1. The issue is this negative 1/4 is only on the x, not on the 2. So we've got to only move the x down and it would be underneath a 1. But that 1 would be multiplied by the 2. So the 2 is going to stay up top, and it would get multiplied by that 1 that would be there. So we're just going to call it a 2 on top. On bottom, in the denominator, we'd call it x to the 1/4. So 2 over x to the 1/4. That's our answer. Oh, I probably should have boxed this one in. That's the answer. That's the answer for B. C, we've got 8.3 to the 3/4 raised to the 2/3. We're going to multiply those because it's power raised to a power. So 8.3, that's going to be to the... I didn't need the parentheses, so... Oh, shoot. I think I screwed it up. Sure did. Well, parentheses are going to stay, because I can't change them now. So it'll be 3/4 times 2/3. That gives me 8.3 to the 6/12. And 6/12 is 1/2, so we got 8.3 to the 1/2. And we're going to leave it just like that. D, you've got x to the negative 2/5, y to the 1/3, both raised to the 1/2. We're going to kind of distribute that 1/2 through all the powers and multiply through all the powers in there. So we're going to have x to the negative 2/5 times 1/2, and y to the 1/3 times 1/2. And if we multiply those, we're going to get x to the negative 2/10, y to the 1/6. 2/10 is really 1/5, so x to the negative 1/5, y to the 1/6, and negative 1/5 we don't want to leave that there, so we're going to move that x down below the y and make it positive 1/5. So y to the 1/6 divided by x to the 1/5. That's your answer for D. Pause here, try your checkpoints. When you come back, I'll give you the answers. So we've got checkpoint 6. Simplify for A, you get 7 to the 1/6. B, you get 5 over x. C, you get 9.1 to the 3/10. And D, you get 1 over 1/12, or y to the 1/12 over x to the 1/5. Y to the 1/12 over x to the 1/5. Let's look at simplifying radical expressions on the next page. So we've got simplify radical expressions using rational exponents, because there are other ways to simplify radicals, but this is going to be using rational exponents. And so the first step in doing that is rewrite each radical expression as an exponential expression with a rational exponent. Then 2 is simplify using properties of rational exponents. And the last thing is rewrite any radical notation rewrite in radical notation if there's rational exponents that still appear. So we don't want any fractions for exponents in the end. Let's look at some examples. You've got 10th root of x to the 5th. Okay, so we're going to write it as rational exponents, so that would be x to the 5/10, which is the same as x to the 1/2 if we reduce the fraction. And we don't want any radical exponents. I'm sorry, any rational exponents. So if we can't have a rational exponent, we're going to change it back to a radical, which is the square root of x. That's our answer. For B, we're going to do the same thing. Change it to a expression with rational exponents. So it would be 27 a to the 15th all raised to the 1/3. And we would take each number, the 27 but to the 1/3, and we'd take a to the 15th to the 1/3. So we'd get 27 to the 1/3. A to the 15th to the 1/3, you'd multiply the 15 times 1/3. So that would be a to the 15 over 3, which is the same as 5. But 27 to the 1/3 is the same as the cube root of 27. And we got a to the 5th. But the cube root of 27 we know is 3, so it's 3a to the 5th. And that's our answer. C. We got the 4th root of x to the 6th y squared. So we're going to rewrite it with rational exponents. So we've got x to the 6th y squared to the 1/4. And then we're going to multiply that 1/4 through the exponents on the x and the y. So it's going to be x to the 6/4 y to the 2/4, which x to the 6/4 is 3/2, x to the 3/2. Let me erase that and get a better 3/2 out of it. X to the 3/2, y to the 1/2 if we reduce 2/4. And you can see each exponent still has a half in it. This one just actually has 3/2, the x does. So I can write this as x to the 3rd y, both raised to the 1/2. And now I can make it the square root of x to the 3rd y. So that one was a little complicated. We've got x times x for D, x times cube root of x. Square root of x times cube root of x, sorry. So we're going to write them as rational exponents. That's x to the 1/2 times x to the 1/3. And we're going to have to add exponents in order to combine them. That means we've got to get a common denominator. We have 1/2 and 1/3, the common denominator is 6. So 1/2 is 3/6 times x to the 2/6. The 1/3 is 2/6. So now we can add them up. X to the 3/6 plus 2/6. That gives me x to the 5/6. And we're going to write it as a radical. Would be the 6th root of x to the 5th power. And I'm going to slide this, I don't know if I can. I'm going to have to just deal with it the way it is. On E. I can barely fit this in. We're going to change the inside one first. So we got the cube root of the square root of x. So we're going to change the inside to the cube root of x to the 1/2. To make that rational exponent first. And then I can take that and I could say, all right, the cube root means raise it to whatever we're taking the cube root of. Raise that to the 1/3. It's cube root. So we've got x to the 1/2 raised to the 1/3. And a power raised to a power I multiply. So I'm going to multiply the fractions. On top, the 1 times 1 is going to give me 1. On bottom, 3 times 2 is going to give me 6. But I don't want rational exponents, so I got to change it back to a radical. It's the 6th root of x. So there's that answer, and there's that answer. That's all for today. I will see you in class tomorrow.